Hello and welcome to this session on databases. Although we have discussed the fundamentals of databases, data warehouses, and data marts in the earlier session, today we will continue to discuss database and we will also see how databases can be designed in organizations. These are the learning objectives of today's session. We'll be discussing all these objectives. In this session, we'll discuss the role of databases for managing firms' data and providing the foundation for business intelligence. All of you uh, must have come in contact with a database at your work or when you are making use of the web for personal purposes. Google, Amazon, all of you would have been regularly be using. These are database-driven websites. When you are making travel reservations, you are making use of a website and databases. Facebook, iTunes, Twitter, when you are using social media, you are also using databases. You must be wondering why these sites are driven by databases. What is it all about databases and how are databases created and used? And more often, these sites, how they are connected to databases and improve efficiency of the users. That's what we are going to discuss. We will be focusing on first, what are the problems of managing data resources in a traditional file environment. That is the first objective that we'll be discussing. What are the major capabilities of database management systems and why is a relational database management system so powerful? What are the principal tools and technologies for accessing information from databases to improve business performance and decision making? Why are information policy, data administration, and data quality assurance essential for managing the firm's data resources? Better data management, all of you should know, helps organizations and managers. Whenever you are faced with problems such as the one shown, like if data are fragmented in isolated databases and files, it's a problem that needs to be addressed. If data is not managed properly, it becomes time consuming for the reporting processes. Outdated data management technology can also create problems. Now, what is the solution that you need to have in order to solve these problems? You need to just replace the die-separate systems with a integrated database system with centralized mainframe and data management application systems. All of you should know that in an age of non-organic corporate growth, where companies grow by acquiring other companies, business firms quickly become a collection of hundreds of databases and systems, personnel systems, accounting systems, manufacturing systems, and none of which can communicate with one another. So even if firms grow organically without acquisitions, it is common for separate departments. It is common for separate departments and divisions to have their own systems and databases. Firms in this case suffer the same result. The firm becomes a collection of systems that cannot share information. This creates a demand for powerful enterprise-wide or firm-wide databases or integrated databases that can bring order to the chaos. So databases and data warehouses come as a solution for managers and companies because they contain all of a company's data. Users need to educate themselves with the tools and then use them to reap the benefits of databases, and it can happen only with better data management. IT plays an important role in successful data management. Digital technologies have the ability to lower costs while improving performance for any organization. This particular slide describes a hierarchy of data that is used to store information in databases. Progressing from the database as the top level holder of information down through the field which stores information about an entity and the entity's attribute. This hierarchy that you see on the slide is illustrated by a graphic on the next slide, which I'll show you later. After a discussion on this particular slide, you should be able to come up with some other entities that you can think of that might be found in a university database, uh, and what are the attributes that each of these entities can have. And that is important to understand the hierarchy of data. So if you take a look, data is organized as fields, records, files, and finally as a database. As I discussed in the last session, the smallest unit of data that can be processed and stored in a computer is bits, and 8 bits, which are logically related, make up a byte. And a set of related bytes actually creates a field. Field is nothing but a group of characters, such as word or words or number. The field describes an entity. It describes an entity, that is, anything under the sun can be considered as an entity, a person, place, thing on which we store information. And each of these entities have their attributes. Each of the entities have some characteristics or quality describing it. So for a particular entity, the attributes can be date or grade or name or age or qualification, which can either belong to a student or some other entity. So date and grade can be considered as an attribute for the entity course. So field is nothing but a group of characters, such as a word or words or number. And a set of related fields is called as a record. It's nothing but a group of related fields. And a group of related records become your file. File is nothing but a group of records of the same type. So when you have a set of logically related files, you have a database. So in databases, we store information regarding entities and their attributes and the relationship that is established between uh, the attributes and the relationship that one entity has with other entities. So this particular slide, this graphic illustrates the hierarchy of data that is found in a database that we discussed just now. If you take a look at the data hierarchy graphic, you'll see that it shows the student's course file, grouped with files on students' personal histories and financial backgrounds that form the student database. It illustrates what data is found at each hierarchical level from the database level down, making out the smallest information unit. The field are the small units of data common to all applications. As I just now told you, bits and bytes. A bit stores a single binary digit, 0 or 1, and a byte stores a group of digits to represent a single character, number, or other symbol. So this particular slide discusses how a computer system organizes data in a hierarchical manner that starts with a bit, the lowest unit that can be processed and stored, which is represented either through a 0 or a 1. Bits can be grouped to form a byte to represent one character, number, or symbol. As I told you, bytes can be grouped to form a field, and related fields can be grouped to form a record, and related records can be collected to form a file, and related files can be organized into a database. That's what you see in this slide in the graphics that is shown to you. Managing data in a traditional file environment created many issues or many problems. The general problems with the traditional file environment, when files were maintained separately by different departments, it created many problems. So this slide discusses the problems in data management that occur in a traditional file environment. In a traditional file environment, different functions in the business like accounting, finance, HR, etc., maintain their own separate files and databases. Data redundancy was one of the typical problems faced by managers while using the traditional file. The presence of duplicate data in multiple files can be a problem. It can make the processing of data slow, and storage becomes costly because the same data is duplicated in many places, which is not required. Data redundancy leads to data inconsistency. And all of these problems that we'll be discussing makes the database, the file, inflexible. So data redundancy leads to data inconsistency. That means the same attribute will have different values in different places, which can lead to a problem. Like if data is stored in different separate places, if in one place I have updated my address, the address may not have been updated in other places because the same data was stored in isolated places and they were not integrated. So updating the address may not have been reflected in other places, which can lead to a problem. So data redundancy leads to data inconsistency, and data inconsistency can be a huge problem, making the database or the file very difficult to be used. So another problem in the traditional file environment is that data will come into the organization. Every time new data comes, we needed to change the program because data was closely integrated with the program that processed it. So that can be a problem. A good programmer may not like to change the program that he is designed again and again every second when the data changes. So program data dependency was a huge problem in the traditional file environment. When changes in program, it required changes to the data also, which was accessed by the program. So traditional file system also had lack of flexibility. It had poor security because it was saved in isolated places. It also had lack of data sharing and availability. This particular this particular graphic shows you or illustrates a traditional file environment in which different business functions maintain separate data and applications to store and access that data. Okay. So the use of a traditional approach to file processing encourages each functional area in a corporation to develop specialized applications. Each application requires a unique data file that is likely to be a subset of the master file. These subsets of the master file lead to data redundancy and inconsistency. It also leads to processing inflexibility and waste storage resources. So this was not a ideal method to store data in files. So the new approach came up wherein all these applications that you see in this diagram were integrated to a single database, and the applications were clubbed together to form what was called as a database management system. So this particular slide describes two things: the database and the database management system. The database is the storehouse where the data is stored, and the data that is stored in that storehouse is manipulated by a set of application programs, and that set of application programs is called as a DBMS. So a database basically serves many applications by centralizing data and controlling redundant data. And database management system is the application program which establishes an interface between the applications and the physical data files. It separates the logical view of data from the physical view of the data. It solves problems of the traditional file environment by controlling redundancy, by eliminating inconsistency, by coupling programs and data, and by enabling organization to centrally manage data and data security. This graphic illustrates what is meant by providing different logical views of data. If you take a look at the last two rectangles, it shows that these rectangles represent two different views in an HR database, one for reviewing employee benefits, the other to review or the other to access the payroll records. So we can think of the green cylinder as the physical view, which shows how the data are actually stored on the media, on the physical media. The physical data do not change. The DBMS, all of you should know, can create many different logical views to suit different needs of users. So this slide introduces you to the most common types of DBMS that are used with personal computers, servers, and mainframes today. The most popular, as I have told you in the earlier session, that the relational data model or the relational database is most popular with the businesses. It uses relational algebra and relational calculus to store the data and to manipulate the data. So relational database management systems basically represent data as a two-dimensional table. So that data can be stored in rows and columns. And each table contains data on the various entities and the attributes and their attributes. The table is nothing but a grid of columns and rows. The rows are called as tuples. That is, it shows the records for different entities. The fields are the columns. They represent the attribute for entities. And all databases will have a key field, the field used to uniquely identify each record, and the unique key is called as the primary key, the field in the table which is used for key fields. As I told you in the last session, that your registration number can be the primary key, and databases can also have foreign keys, that is the primary key used in the second table which is linked to the first as a lookup field to identify records from the original table. This graphic illustrates two tables in a relational DBMS. A relational database organizes data in the form of two-dimensional tables, as you can see here. Uh, these are the tables for the entities supplier and a part showing how they represent each entity, the supplier and the part, and their attributes. Supplier number is the primary key for the supplier table and a foreign key for the part table. If you see, it's a foreign key for the part table. So the primary key of one table can be the foreign key of another table. The foreign key of one table can be the primary key of the previous table. Okay. This slide describes you how information is basically retrieved from a relational database. Uh, you can carry out operations like select, join, and project. These are nothing but programming statements and are used by the DBMS or the RDBMS developers. For example, if you want to select uh, the last two slides showing the supplier and parts table, you would use a particular type of operation to show the parts records along with the appropriate supplier's name. Then you can use a particular operation. You will see that Microsoft Access has wizards for these commands for selecting, for joining, and projecting. So the operations of a relational database management system that you normally carry out are of three types. There are three basic operations which are used to develop useful sets of data. The most widely used operation is the select operation, which basically will help you to create subsets of data of all records that meet a stated criteria. Join, when you have more than 2-3 tables which are logically related. Join will combine relational tables to provide user with more information than available in individual tables. And project basically will create subsets of columns in the table, creating tables with only the information specified. This graphic that you see on the screen illustrates the result of from combining the select, the join, and project operations to create a subset of data. The select operation basically retrieves just those parts in the part table whose part number is 137 or 150. The join operation, if you see, uses the foreign key of the supplier number provided by the part table to locate supplier data from the supplier table for just those records selected in the select operation. Finally, the project operation, if you see the last table, the table at the bottom, the project operation limits the columns to be shown to be simply the part number, the part name, the supplier number, and the supplier name. Here we discuss other types of DBMS that are available for managers to use. One type is called as relational database, and another type is the databases that are found in clouds. Okay. Non-relational databases are more flexible data models as compared to the other data models, the hierarchical network or the relational data model. Data sets are stored across distributed machines in NoSQL. It is easier to scale. It handles large volumes of unstructured and structured data. So whenever you are working with web, social media, and graphics, you can use NoSQL instead of the other data models that I just spoke about, hierarchical network or relational data model. Today, databases are also available in the cloud. Typically, these have less functionality than on-premise databases, but they can be also beneficial. Amazon Relational Database Service uses databases in the cloud. Uh, so private clouds can provide this facility. Now, what are the capabilities of database management system? There are basically three capabilities. The data definition capability, which is called as the DDL. It specifies the structure of database content used to create tables and define characteristics of fields. Then you have the data dictionary. It is nothing but an automated or manual file for storing definitions of data elements and their characteristics. Data manipulation language is the third capability that you find in RDBMS. It is called as DML. It is used to add, change, delete, retrieve data from databases. So all these capabilities are clubbed together and put in one tool called as the structured query language. So many DBMS have report generation capabilities for creating polished reports like crystal reports. This particular slide shows this graphic shows the data dictionary capability that is available in Microsoft Access. For the field supplier name, if you take a look for the field supplier name selected in the top pane, definitions can be configured in the general tab in the bottom pane. These general characteristics are the field size, format, input, mask, the input mask, the caption, the default value, the validation rule, uh, the validation text that is required, the index, the Unicode compression. It shows IME mode, it shows IME sentence mode, and smart tags. So basically, Microsoft Access has a rudimentary data dictionary capability that can display information about all of these, the size, the format, and other characteristics of each field in a database. Displayed here in this particular slide is the information maintained in the supplier table. This shows the details of the supplier table. The small key icon that you see to the left of supplier number indicates that it is a key field. This particular icon shows uh, that the field is nothing but a key field. This particular slide illustrates an example of a SQL statement that would be used to retrieve data from a database. In this case, the SQL statement is retrieving records from the part table uh, that was illustrated in the previous in this particular in the next slide in the next slide in the next slide. Okay, so in this case this particular SQL statement is retrieving records from the part table that is illustrated in this slide, whose part number is either 137 or 150. Okay. So this particular slide actually illustrates a Microsoft Access query that performs the same operation as the SQL query in the previous slide that you saw. So the query pane at the bottom, that you see uh, shows the fields. Shows the fields. These are the fields. These are the shows the fields, the relevant tables, the relevant tables, uh, the fields that will be displayed in the results, and the criteria limiting the results to part numbers 137 and 150. That is the criteria that we have fixed. Here we describe the various activities involved in designing a database. To create an efficient database, you must know what the relationships are among the various data elements, the types of data that will be stored, and how the organization will need to manage the data. Please note that the conceptual database design is concerned with how the data elements will be grouped, what data in what tables will make the most efficient organizations. So please take a look at what are the capabilities of database management systems. For designing databases, the conceptual logical design or the abstract model from the business perspective needs to be designed first. Then we go on to design the physical design. That is, how databases are to be arranged on direct access storage devices. You need to plan that. So you use RDBMS to design databases through the language called as data definition language. The design process should identify not just the logical and physical design, but it should also show the relationships amongst the data elements and the redundant database elements, and the most efficient way to group data elements to meet business requirements and the needs of application programs. So in order to come up with a streamlined database, the database which has uh, the pure data saved in rows and columns, which can be processed or manipulated to generate good quality reports. The process used to come up with a good database design is either a entity attribute relationship diagram, or we go through the process of normalizing. A normalization is nothing but streamlining a complex groupings of data to minimize redundant data elements and awkward many-to-many relationships. This particular slide uh, illustrates the process of normalization. Here, one table lists the relevant data elements for the entity called as order. These include the order number, the order date, part number, part name, unit price, part quantity, supplier number, supplier name, supplier street, supplier city, supplier state, and supplier chip, which are nothing but the fields within the order, the part, and the supplier entities for the order, part, and supplier entities. So this shows an unnormalized relation containing repeating groups. An order can include more than one part, and it may be that several parts are supplied by the same supplier. However, using this table, the supplier's name and other information need to be stored several times on the order list. So if you take a look closely at this particular unnormalized relation for order, you find that it contains repeating groups, I can give you an example that there can be many parts and suppliers for each orders, and there is only a one-to-one correspondence between order number and order date. This shows the normalized tables. The order table has been broken down into four smaller related tables. Here, please notice that the order table contains only two unique attributes: order number and order date. The multiple items are stored using the line item table. The normalization means that very little data has to be duplicated when creating orders. Most of the information can be retrieved by using keys to the part and supplier tables. It is important for us to note that relational database systems try to enforce referential integrity rules that ensure that relationships between coupled uh, uh, that relationships between couple tables remain consistent. When one table has a foreign key that points to another table, you may not add you may not add a record to the table with the foreign key unless there is a corresponding table or record in the link table, the corresponding record in the link table. For example, I can say that the foreign key supplier number, this particular number, supplier number links the part table to the supplier table, part table to the supplier table. You see, it exists here in the part table also. Referential integrity means that a new part cannot be added to the part table, to this table, to the part table without a valid supplier number existing in the supplier table. It also means that if a supplier is deleted from the supplier table, any corresponding parts must be deleted also. So after normalization, the original relation order has been broken down into four smaller relations. The relation order is left only with only two attributes, and the relation line item has a combined or concatenated key consisting of order number and part number. Here, we continue to discuss about designing databases. One technique database designers normally use in modeling the structure of the data is to use an entity and relationship diagram, which I'll show you in the next slide. So, symbols on the diagram will illustrate the types of relationship between the entities. So here we have described what do we mean by referential integrity rules. They are used by all RDBMS to ensure relationship between tables remain consistent. And an entity relationship diagram is used by database designers to document the data model. It can also illustrate the relationship between the entities. But caution that need to be kept in mind. If a business does not get data model right, system will not be able to serve the business well. So designing the database is an important activity for all information system managers. So this particular slide shows an example of an entity relationship diagram. It shows that one order can contain many line items. A part can be ordered many times and appears many times as a line item in a single order. Line item can contain only one part. Each part can have only one supplier, but many parts can be provided by the same supplier. So this illustrates the diagram which shows the relationship between the entity supplier, part, line item, and order that might be used to model the database. Uh, the various tools for improving business performance and decision making that are widely used by managers and organizations today. One is big data. You just don't use small data or small databases to store data in rows and columns or structured data that can be stored in rows and columns. But today, there is a requirement to store data which cannot be put in rows and columns, like Facebook clicks, Twitter posts, Instagram posts, Facebook posts. All this cannot be saved in rows and columns. So a new tool has come up wherein we can store unstructured or semi-structured data from the web traffic, social media, sensors, and so on. And that we term as big data. So these take a hell lot of storage space because petabytes, exabytes of data are used by them. So these are volumes which are too great for typical DBMS to handle. So we look for tools which can handle this kind of big data. And today organizations have realized that 80% of the value from databases come from unstructured and semi-structured data because they can reveal more patterns and anomalies. Business intelligence is a very amorphous notion that is not well defined. Uh, Instead of business intelligence environment, which is composed of different components, including both technology and management dimensions, we use the term databases. We also talk about large databases or intelligent databases which make good use of OLAP, called as data warehouses, data marts, are function specific databases. To handle big data, we use Hadoop. We also use other contemporary tools to handle structured, semi-structured, and unstructured data, such as in-memory computing and analytical platforms. So a data warehouse, as I told you, uses OLAP and uses intelligent agents. Also uses, as we have seen in the earlier sessions, it uses a process called as ELT in order to transform the data from the database to be utilized by the users. So a data warehouse normally stores current and historical data from many core operational transaction systems. It consolidates and standardizes information for use across enterprise, but data cannot be altered. It can also provide analysis and reporting tools. Data marts are smaller data bases. They are a subset of data warehouses. Uh, um, they are nothing but they provide the data in a summarized or focused portion of the data can be displayed for use by specific population of users. So you can have a marketing data mart, you can have a HR data mart, a function specific database. It typically focuses on single subject or line of business. This diagram illustrates the components of a data warehouse system. It shows the data warehouse that extracts data from multiple sources, both internal and external, including a Hadoop cluster, and transforms it as needed for the data warehouse systems. An analytical platform has tools for power users, including reporting, OLAP, and data mining to extract meaningful information from the data warehouse and Hadoop clusters. A subset of the data warehouse is collected in a data mart for casual groups of users. So, a contemporary business intelligence infrastructure features capabilities and tools to manage and analyze large quantities of different types of data from multiple sources. Easy to use query and reporting tools for casual business users and more sophisticated analytical tool sets for power users. Hadoop is an interesting tool to handle big data or unstructured and semi-structured data. It enables distributed parallel processing of big data across inexpensive computers. That's why Hadoop is very popularly used by organizations, is very popular amongst managers and organizations to handle big data that can be handled across inexpensive computers. Key services that Hadoop provides is the HDFS or the Hadoop distributed file system for data storage. It also provides another key service called as MapReduce to break data into clusters of work. It also provides HBAS, which is nothing but an NoSQL database. So Hadoop, Facebook, Yahoo, Nextbio, Netflix, many of these organizations, web-based organizations, use Hadoop in order to carry out data processing and to generate reports. In-memory computing is another important tool for improving business performance and decision making apart from databases and big data bases. So in-memory computing is used in big data analysis. It uses computer's main memory, RAM, for data storage to avoid delays in retrieving data from disk storage. It can reduce hours per days of processing to seconds. So, it requires optimized hardware. You can also implement analytical platforms in the organization to handle data or to manage data. Analytical platforms are nothing but high-speed platforms using both relational and non-relational tools optimized for large data sets. You can also use analytical tools for establishing relationships, for finding out patterns, for finding out trends. These are nothing but tools for consolidating, analyzing, and providing access to vast amounts of data to help users make better business decisions. Multidimensional data analysis is done through OLAP, not OLTP. You can carry out data mining, text mining, web mining. So online analytical processing is important in all these intelligent databases because they support multidimensional data analysis. You can view data using multiple dimensions. Each aspect of information like product, pricing, cost, reason, time period can be looked into very easily. OLAP enables rapid online answers to ad hoc queries. That's why it is very popular amongst managers. This shows a multidimensional data model. Uh, the view that is showing is that of product versus region. If we can rotate the cube 90 degrees, the phase that will show product versus actual and projected sales. If we rotate the cube 90 degrees again, we'll see region versus actual and projected sales. Other views are also possible. So this particular slide actually forces us to understand that the concepts, to understand the concepts of dimensions as it relates to data. Product is one dimension, east is a dimension, and projected and actual sales are two more dimensions. Although we are trying to analyze four dimensions, the business question is, in the eastern region, what are the actual projected sales of our product? If we are selling nuts, bolts, washers, and screws, that can give an answer. OLAP can provide us with an answer, sometimes referred to as a data cube. A multidimensional data model is sometimes referred to as a data cube. So this graphic can depict this four-dimensional view of the data. More importantly, when compared to a spreadsheet model of the same data, a graphic data cube is much faster, easier to understand and visualize the relationships. That's why OLAP is very popular amongst managers. Data mining is a tool used by managers to find hidden patterns, relationships in large data sets. If you want to find out the customer buying patterns, you have to use data mining tools to drill down into large data sets to generate non-obvious patterns and trends. You can infer rules to predict future behavior using data mining. Various types of information are obtainable from this particular intelligent tool that is used on databases. You can find out associations, sequences, you can classify, you can do clustering and forecasting. Also, text mining can be done. You can extract key elements from large unstructured data sets. You can do sentiment analysis using these using the tools to mine into emails, blogs, social media to detect opinions. Web mining is also possible. Web mining is also possible to discover and analyze useful patterns and information from the web. To understand consumer behavior, we use web mining. To evaluate the effectiveness of websites and so on, we can use web mining. And we can also carry out web content mining to mine content of the web page. We can analyze links to and from the web page using web structure mining. We can also mine user interaction data recorded by web servers using web users mining. So, databases and the web are the talk of the town today because many companies use web to make some internal databases available to customers or patents. Typical configurations include web servers, application servers, and database servers for hosting the domains. You get many advantages of using web for database access because it is easy to use. The web interface requires few or no changes to the database, and it provides inexpensive methods to add web interface to the system. This shows how the way data is passed from a database through to a user with a web browser. You can see that the client is having the web browser and he uses the internet to access the web server, the application server, the database server, and finally the database. So users access an organization's internal database through the web using the desktop and web browser softwares. In order to manage data better, every organization needs to establish an information policy. That is, the firm should establish rules, procedures, roles for sharing, managing, and standardizing data. Data administration is a key area which needs to be focused on by every organization and every manager because it establishes policies and procedures to manage data. Data governance is another key area that needs to be focused on while dealing with better data management as it deals with policies and processes for managing availability, usability, integrity and security of data, especially regarding government regulations. Database administration is one of the key activities of every information systems manager for creating and maintaining databases. So, as a information systems manager or as a database manager, we need to ensure data quality. We need to handle redundant data, inconsistent data, and faulty input properly in order to ensure that the data is of quality to be processed, analyzed, and the reports to be generated. Before new database is in place, you need to identify and correct faulty data, establish better routines for editing data once database is in operation. You need to very often carry out a data quality audit which is a structured survey of the accuracy and the level of completeness of the data in an information system. You need to clean the data. So data cleansing is nothing but a process wherein software is used to detect and correct data that are incorrect, incomplete, improperly formatted, and redundant. Data cleansing also enforces consistency among different sets of data from separate information systems. So today we have discussed database in detail. In the next session, in the final sessions, in the concluding session, we'll see how database is designed and other aspects of this block in order to have a very good understanding of data management in organizations. Thank you.